Welcome to the world of technological innovation, where engineering merges the power of nature with modern efficiency. Today, we're introducing a technology that could transform the way we handle solution concentration, water desalination, and industrial resource recovery. This is the fusion of two groundbreaking solutions: Drum Film Evaporators, DFE, and Mechanical Vapor Recompression, MVR. Drum film evaporators are the heart of this system. Their principle of operation is simple yet incredibly effective. Inside the unit, a rotating drum is covered with a thin layer of liquid. Heat is transferred through the drum wall, causing evaporation. What makes DFE unique is its ability to handle even the most complex solutions without the need for extensive pretreatment. Scaling and deposits are no longer an issue thanks to the built-in self-cleaning system. Within the drum operates a screw, a cutting-edge mechanism that rotates beneath the liquid level. This component serves two critical functions. It cleans the inner surface of the drum to prevent scaling and transport sediment to the discharge point. This allows DFE to process highly concentrated and contaminated solutions without frequent shutdowns for maintenance. Now let's add MVR, Mechanical Vapor Recompression, to this system. This technology allows the reuse of vapor generated during the evaporation process. Instead of venting or cooling it, Roots blowers compress the vapor, increasing its temperature and pressure. This reheated vapor is then reused to heat the liquid in the system. This closed-loop approach reduces energy consumption to a minimum, making the plant almost entirely self-sufficient and independent of external heat sources. Why is this important? Let's compare. Traditional evaporation methods like multi-stage flash, MSF, or multi-effect distillation require significant amounts of heat and electricity. The combination of DFE and MVR reduces energy consumption by 3 to 4 times by using mechanical energy to recover heat. This not only saves resources, but also significantly reduces the carbon footprint. Examples of applications of the technology. The DFE and MVR technology is a universal solution that finds applications in a wide variety of industries. Here are just a few examples. 1. Metallurgy. In aluminum production, the Bayer process requires the concentration of alkaline solutions. DFE handles this task without the risk of scaling, while MVR minimizes energy consumption. 2. Water desalination. In regions with limited access to fresh water, such as North Africa or the Middle East, desalination is critical. DFE and MVR enable a complete recycling process without the discharge of toxic brines, protecting the environment. 3. Radioactive waste management. In nuclear energy, minimizing the volume of liquid radioactive waste, LRW, before final isolation is crucial. DFE technology allows these solutions to be concentrated to the maximum level, simplifying further processing. 4. Food industry. DFE is used for concentrating dairy products or fruit juices while preserving their nutritional and flavor properties. 5. Chemical industry. This technology is applied to regenerate acids and alkalis, reducing raw material costs and waste disposal expenses. Every industrial process faces unique challenges, but one of the most persistent issues is the formation of aerosols during the evaporation of solutions containing surface active substances. These tiny liquid droplets carried by steam often contain salts, organic compounds, and other contaminants, posing risk to equipment, reducing process efficiency, and impacting the environment. This problem becomes especially critical when working with drum film evaporators. If the solution tends to foam, aerosol carryover intensifies. This degrades condensate quality, causes deposits of salts and organics on heat exchange surfaces, and increases the risk of corrosion and equipment wear. The solution lies in a patented technology for a heat and mass transfer apparatus that efficiently cleans secondary steam of aerosols. How does it work? It's simple yet ingenious. The steam passes through specialized elements in the apparatus where larger droplets and aerosols are removed using inertial and centrifugal forces. Close-ups of the apparatus highlighting key benefits. The heat and mass transfer apparatus offers numerous advantages. Comprehensive steam purification. Even the smallest droplets are removed, ensuring clean condensate. Equipment protection. Eliminating aerosols prevents deposits and corrosion on surfaces. Environmental friendliness. Minimizing emissions makes the process safer for the environment. Flexibility. The apparatus integrates seamlessly into any evaporation process, enhancing system stability. Most importantly, it ensures stable performance even with solutions prone to foaming. The interaction between the heat and mass transfer apparatus and the drum film evaporator creates a robust system capable of efficiently concentrating even the most complex solutions. Heat and mass transfer apparatuses represent a leap forward in aerosol management. Efficiency, reliability, and eco-friendliness make them an essential part of modern industrial processes. Technology for today, processes for a sustainable tomorrow. What makes this technology revolutionary? First and foremost, it is remarkably simple to operate. The systems require no complex setup, chemical reagents, or high-tech materials. All it needs is steam, drum rotation, and energy for the blowers. This makes the setup accessible even in regions with limited infrastructure. Traditional evaporation methods, such as evaporation ponds or basic steam systems, often require large land areas, high energy input, and complicated maintenance. In contrast, DFE and MVR minimize the footprint, operate faster, and incur lower costs. This system is not just an engineering solution, it's a step toward sustainable development, toward a future where solution concentration becomes simpler, cheaper, and more eco-friendly. Today, DFE and MVR technologies are reshaping industrial processes, allowing us to optimize operations and care for our planet.